My name's John Barrett, founder of Sustainable Engineering. I started my working career on a fishing trawler in the North Sea, of all places. The reason I mention that will become apparent later in the presentation. I then went on to study product design, three-dimensional product design, so that's my academic background. And I was involved in the design of high-speed automation and robotic systems, first part of my career, so I've got some practical engineering background. I then went on to start writing about engineering, and over the last 30 years I've edited a number of engineering magazines, mechanical, electrical, electronic magazines over that period. 20 years ago started a software development business, which is I'm still involved in today, developing web-based applications primarily in the publishing sector. And now I find myself working in the area of sustainability. We fight wasteful design because sadly there is a lot of wasteful design in the world today. It originates from many different places, and it's preventing the engineering and manufacturing sector from migrating from a linear economy to a circular economy. And we're hopefully going to be playing an early role in this. It all started a couple of years ago when I went to a net zero conference to find out what the carbon footprint of our own business was. While I was there, some engineers were presenting their vision for how they could reduce the environmental impact of their products and processes, and I was mesmerised by the work they were doing. And I wanted to know what was incentivizing them, and also what was preventing them from pushing on with that work. So we started a research project which ran for about 6 months to look at the driving forces that were pushing forward sustainability within the engineering sector. And we found 6 things. One was a stick, which was legislation. And then there were some carrots: business innovation, social, profit, people, and moral. From today's kind of theme, probably one of the most interesting is going to be around people in terms of recruitment and retention, because that's one of the big driving forces at the moment. Engineering companies are finding it very difficult to find good people, and when they do find them, they're finding it difficult to keep hold of them. And the other thing that I'm going to loop back to at the end of this presentation, because it's actually quite quick, is legislation. Because 2024 is a big year for legislative impact in the engineering sector, and it's really going to accelerate the process from now on. So what did we do next? Well, we went on a 12-month journey of discovery and validation. It was pretty intense. There were 3 of us on this essentially full-time. We conducted over 700 face-to-face interviews. We attended 22 engineering exhibitions. We've built up LinkedIn, over 4,000 LinkedIn connections, and started to attend a lot of virtual events that are accelerating as well. And from all of that, that's where we gathered all of our information and data that we then used to move forward with. And what did we discover? We discovered that design engineers, they don't really know where to start. Where do you start if someone says, improve the sustainability of your products? Okay, start point is a tricky one. Then what questions do you need to ask? If you're facing all of that legislation we saw back there, what to do and who to trust in the process? It's a little bit like the Wild West at the moment, the sustainability sector. There's a lot of different messages coming from a lot of different directions, and you need to navigate your way through that, and it's quite complicated. The suppliers to the engineering sector, they're doing a lot too, but they've got their own issues in terms of what to say. There's an interesting thing: suppliers are very nervous about accidentally greenwashing their business. And if you look at some legislation coming through from Europe and the Advertising Standards Authority, that's actually going to be legislated from what we can tell in terms of what you can and can't say about the sustainability of your activity. So that's interesting. How to say it? Sustainability means different things to different people. For some people it means offsetting and scope 1, scope 2 emissions. To other people it means a certified environmental product declaration. That's a completely different kettle of fish. So what do you say? Who do you say it to? And then do you have the time and resources to do all of that? Because they're busy doing everything they already do. We also discovered some mega trends that are feeding into sustainability. Digitization. If you can do things digitally rather than physically, you can reduce a lot of waste, you can speed your time to market, you can not make as many mistakes en route. Additive manufacturing. It's a process where you can make lot size 1. You don't have to mass manufacture something and use a lot of materials and resources. If you're machining something on a lathe, essentially you're producing swarf. The products is what's left behind. With additive manufacturing, there is no swarf. And then something called servitization, which is also known as product as a service. So rather than manufacturing a product, selling it and abandoning it, you actually completely reverse your business model and you manufacture a product and then you earn future revenue from servicing it, maintaining it, upscaling it, repairing it and keeping it in the market for as long as you possibly can. And we're already witnessing examples of that actually taking place in big engineering organisations around the world, and I can come back to that. It's absolutely fascinating. And then what about our own goal? It's very difficult for me to come up and talk about this without us being able to do everything we can to fit in with this process, because people will ask me questions. They'll say, yeah, that's great, John, but what are you doing? Well, our business is actually based around a software platform, which I'll come on to next. And what we decided to do was abandon all our previous software development knowledge, essentially, and go to a pure green coding base. And when I show the product in a moment, I won't dwell on it, but it has a world-leading carbon footprint per visit. And that's been verified by Website Carbon. And then something else we're looking at that Michelle is focusing on is B Corp registration, which is essentially a rewrite of our company's operations, putting in pledges to work in a sustainable fashion. So what we actually discovered, this is the centre of our kind of discovery. It's that engineers, who are the unsung heroes of the future of a sustainable world, they hold the key to making the decisions that will reduce the impact of products on the environment, and they hold the key to transforming their businesses to a circular economy. These are the 10 R's that are often used. It used to be 3 R's, it's now 10. I dare say over time it will expand. A product design brief once upon a time was performance and cost. That's pretty much it. Does the product do what we want it to do, and can we do it affordably? Now there's 10 more things to think about. And that's going to come as a surprise to some design engineers when they start to encounter this. Over here on the supplier side, so the companies that are supplying the components, the materials, the technologies, the processes, the services, etc., they're already doing a ton of this stuff. And that need to work together. And what's missing in the middle is information, communication, and trust. So if these guys can share what they're doing with those people, suddenly sustainable products and circular economies start to become realised. So what are we doing? We're building what we believe will be the first open source database of sustainable products and technologies that design engineers can come and use for a process of learning through serendipity, just stumbling across things that they were unaware of, because that's how a lot of design innovation takes place. And also, most importantly, technology transfer. So we're going to be breaking down all of the attributes. The most important column here is just here. because this is where we start to uncover the sustainability attributes of the technologies and materials, etc., that are supplied into the engineering sector. And we do that through a number of different ways. We've got 13 pillars of sustainability, things like embodied carbon, functional efficiency, minimisation, reliability, design for manufacture, design for disassembly, all of the things, in fact, if I just step back, all of the things that are on this side of the equation just here. The project itself, the actual software itself, was accepted onto the Barclays Eagle Labs starter program, innovation program, and we're just about to release the public beta of this application. On the back end of it, interestingly, it's actually a collaborative writing tool, because what we're hoping to do is we're hoping to help the supplier base that is nervous about accidentally greenwashing and not necessarily sure where to identify the sustainability attributes of their technologies. We're going to help them to craft the messages that they need to produce and then share it via our database. Because we've hand-coded it, it's scalable, and our audacious offer is that we want every supplier of engineering technology in the world to contribute at least one technology from their portfolio that they believe to be the most sustainable. That means that the biggest database of this type should in fact be emanating from Canterbury in Kent, making this a global hub of this type of activity. So there was our rough timeline. We are here, minimum viable product and pitch complete. March, we're going to launch what is known as the minimum viable product with design guides and executive briefing, and then April we scale globally. That's the plan. So we're kind of there. I'm just going to conclude here. I'm actually going to read this out. I was told never read a slide, but I'm going to read this one if that's all right. Every time a design engineer makes a decision, it can have a negative, neutral, or positive environmental impact. Let's work together to ensure that every choice is well informed and right for people, planet, and profit. And welcome to Industry 5.0, because that's what Industry 5.0 is about. It's being able to continue to manufacture products in a way that does minimum harm to people and planet without necessarily doing too much harm to profit. Because if sustainability starts to harm profit, then it's just not going to proceed because it can't afford to. In fact, let me stop here and ask any questions at this point for me. You can do a question. And, one at the back. Sorry. Sorry. Yeah, yes. Yeah, sorry.
My question was actually to do with the servitization.
Yes.
So, am I correct in understanding that's effectively an attempt to undo designer obsolescence?
Yeah. Okay. Some obsolescence is sadly designed in. Some obsolescence is just accidental and can't be remedied by just trying to undo it. A classic example there, one of my sectors is semiconductors. Now, the rate of development in the semiconductor world is unimaginably fast. And so obsolescence by its nature is part of that process, right? So you can't kind of undo that. Servitization is an interesting one. I'm going to give you a very quick example. So one of the biggest sectors in the world is electric motors power over. And the servitization model is not about buying a motor anymore, it's about buying power by the hour. So rather than an engineer saying, okay, I'm going to buy that motor, I'm going to install it, I'm going to turn it on, and then we kind of just let it do its thing. Because electric motors degrade quite quickly over time. So the insulation that would be used in the winding starts to degrade, the bearing starts to degrade, etc. So very quickly, the efficiency of that motor can start to fall. There are motor manufacturers I'm talking to now which are working on the business model, as I say, of power by the hour. So the designer doesn't buy the motor anymore. They decide how much power do I need over what period at what efficiency. The motor manufacturer is then responsible for delivering that. As soon as that efficiency drops below a certain level, they come, they take the motor out, they put it back into their manufacturing process as a resource, and the customer gets a new motor and they're back to maximum efficiency. That's a servitization model. And not only can that motor be refurbished and reintroduced, but over time it can be improved. So the idea is that every time they replace the motor, it gets better and better and better. And there are automotive manufacturers that I've spoken to who are moving into that model where your car just gets better over time, both mechanically and electrically. And that work is underway at the moment. Completely different business model.
Mainly B2B rather than B2C at the moment?
No, not necessarily. No. Kitchen appliances. Yeah. In fact, what's driving it? Well, I'll come on to legislation now. The WE directive, Waste Electrical Electronic Equipment Directive, that's getting a big upgrade, and it's all about producer responsibility. And as the regulations expand, the producer responsibility tends to get pushed further and further out. And so if the producer is responsible for their equipment for longer, it makes a lot more sense to build some revenue into that and turn it into a business model. In the automotive sector, what they've realised is all the materials they need to manufacture a new car already exist in the materials of their existing cars. So if they can bring their existing cars back to the beginning of their production line and use them as their raw material, they don't have to buy any materials anymore. And that's what's starting to now happen. So that is servitisation and circular work. Just on the legislation, I've had to, over the last 2 years, learn so many acronyms that it's becoming almost unmanageable. CSRD, Corporate Sustainable Reporting Directive. ESPR, Eco-Design for Sustainable Product Regulations. Battery Directive, WE, Waste Electrical and Electronic Goods. DPP, Digital Product Passports, that's an interesting one, I'll expand on that. LCA, Product Lifecycle Assessment. ROSH, Restriction of Hazardous Substances. REACH, I can never remember, but that's basically chemicals. CBAM, Carbon Border Adjustment Mechanism. That's where high carbon materials manufactured typically in the Far East will be taxed at the border, starting with fertilisers, cement, aluminium, steel. EPD, Environmental Product Declaration, and greenhouse gas scopes 1, 2, 3, and now 4, which is a new one, which is if you design a product now, how much greenhouse gas will it prevent being generated far into the future? So that's all about kind of efficient motors and that sort of thing. All of those are getting kind of accelerated this year. And for small businesses, they'll say, no, it doesn't apply to me. Yes, it does. Because Corporate Sustainable Reporting Directive applies to very large organisations that either operate in Europe or sell into Europe. But if they're looking at their scope 3, which is inbound supply chain, outbound supply chain, that includes all of their supplier base. So what's happening now is contracts are being renewed, those questions are now being pushed down the supply chain, right down to their smallest suppliers who don't quite know what to do. And so this is going to kind of spread out in that fashion very quickly from this year forward, as far as we can tell. The last slide that I read out, imagine every product has a bill of materials. On that bill of materials, every row is a thing, a component, a material, a process, etc. Every engineer has an opportunity when they're specifying each row to make a good, an indifferent or a bad decision. And our hope is that if engineers can just tackle one row at a time and just keep doing that for long enough, all of those bills of materials will suddenly become much more sustainable than they previously were and be transformative to the manufacturing sector. We've got plenty of case studies starting to come through now showing this taking place. And interestingly, aligning with this event, a lot of the people who are the sustainability leads at these big engineering organisations are female. And there's one woman-owned and operated organisation. It was the first case study I saw. It's a metal finishing company. On your invoice for each piece of of metal that they finish, you now get a carbon footprint to go with the price. That's kind of world first. And that was a software system that they integrated into their machine controllers, developed with a university up in the Midlands as a fantastic example of that. Questions? Yes.
I just want to have a question about the digitization
Yeah.
section that you mentioned. So I'm quite interested to know, like, is artificial intelligence and immersive technologies kind of like looked at in any way by businesses in terms of like
Yes.
incorporating CSR practices within the businesses? Do you think that like, have you come across that a lot?
Yeah, digitisation plays its role in a number of different ways. There's an awful lot of waste that takes place during the research and development phase of product design, because that's where you're playing with ideas. What you want to do is you want to try and scrunch that time frame down and reduce waste. So the big thing is digital twinning. So the idea is before you build the real thing, you build the digital version, you do all the test and R&D in the digital version, then you roll it out, and then you roll a digital version out with it that's monitoring its operation, and you then refine it from there. Some of that is done in CAD systems, but bigger systems like architectural or big machines will be using augmented reality to be able to walk around and through a machine and actually see what's happening in real time. Artificial intelligence, yes, I have my own views on that. It depends whether you're using kind of generative artificial intelligence that is drawing from the entire internet. That's a dangerous thing to do because of the quality control of the data. If you've got a subset that is well controlled and well managed, like a medical application, where you're looking at a defined set of test results or something, then yes, obviously.
When I refer to AI, also generative AI, it's part of it, but I'm more interested in machine learning and deep learning for specific projects, like for example,
Yes.
waste management and things like that.
Yep.
But yeah, thank you, that answers really my question.
Yeah, machine learning in automation, that's my background, is that's how you optimize a machine. You just let it do things and learn from how it does them. I did promise to mention why I refer to my initial career as a fisherman, which has caught me by surprise because the ESPR documentation, I've just got hold of that, that's Eco Design for Sustainable Product Regulations, 300-page document that I volunteered to read so other people don't have to. And what's interesting is to get this ball rolling, they've chosen certain industry sectors to focus on. Of all things, car tyres, mattresses, children's toys, understandable, and fishing equipment, commercial fishing equipment. Well, that's where I started. I started as a fisherman, and then I started manufacturing fishing equipment with my family's firm. And it's fascinating what they're looking for. They want fishing nets to be recoverable, so if they're lost at sea, you can find them. They want to make them so that all of the material in a single net assembly is the same material, so that it can be recycled as a whole rather than having to be disassembled. If it can't be the same material, then it has to be designed in such a way that it can be easily disassembled and then recycled. And in the olden days, we would have blown polyurethane floats on the top. We'd have lead on the rope at the bottom. We'd have nylon ropes. We'd have monofilament mesh. Almost impossible to disassemble easily and quickly. They want lobster pots to dissolve over time, so that if they're lost at sea, they don't act as a continuing danger to creatures in the sea and those sorts of things. So fascinating requirements, and just something I happen to know a little bit about from my background. Yeah.
Not a question, but more like,
sorry.
more like a comment. I'm
Yeah.
not surprised the fishing industry is part of that because a lot of the microplastics within the sea
Yes.
contribute to the pollution. So
Yeah.
it doesn't match, so I'm not 100% sure on, but yeah, the fishing,
Yep.
I can see the narrative behind it.
Yep.
Sorry, Matt.
And I was going to shift gear a little bit.
Yep.
You mentioned the platform and
Yes.
people asking you about the green coding side of it.
Yes.
You alluded to how green coded it is and the
Oh.
carbon output and website carbon.
Yes.
Can you go into a bit of detail about that?
Yeah, so the whole green coding thing is fascinating. many years ago, and I do remember a bit of this, when microprocessors were expensive, memory was even more expensive, and transmission was even more expensive, software developers would try to design the tightest possible code they could, because otherwise it just became unbelievably expensive to buy the hardware you needed to run that. Then hardware, because of Moore's law, etc., suddenly became ubiquitous, and you could essentially just put more processing power into your server to accommodate less efficient code. Now, the problem that has ultimately led to is that data centers are now being demonized for the amount of power that they consume and the amount of heat they consume. Well, what we discovered is not all languages are the same. Some are much more efficient than others. There are, as far as I'm aware, 2 textbooks in the world covering green coding. And we've read them both, and we've deployed those techniques in the platform we've produced. It produces 0.07 grams of carbon per visit. It's A+ rated, better than 94% of other applications on the web. We hope by promoting that side of it, that other organisations will have a go to do the same. Because software, it can have 2 detrimental effects. First of all, it can consume too much power. Secondly, it can also introduce obsolescence. So when you're talking about obsolescence, one of the biggest things driving obsolescence is software. Most of my products at home, most of my kind of mobile electronics, they haven't failed because of hardware issues. They failed because they're no longer supported. So in terms of planned obsolescence, software is actually where one of the biggest problems lies. And so going back to this event, computer science, okay, yeah, we need backward compatibility and sustainability in software development, please. Yeah, so that's what we're doing. We're trying to promote that. There are kind of green coding alliances building up. There's a big one in Europe. And anyone studying software development now, I think I would advise them to have a focus on that. I can't see why you wouldn't. I think it is the trajectory. But it does mean deploying some skills and techniques that aren't necessarily first order. For example, I'll give you a tiny example. You don't just have to think about your server, you have to think about all of the machines that your software will be seen on. Now, on a laptop screen, you've got RGB LEDs, red, green, blue. The blue LEDs consume a little bit more power than the other 2 colours. So if you can start to pull blue out of your application, you will reduce the power consumption of the client computers just by a little bit. But if you've got 1 million users, over time, that adds up to a lot. So that's just one instance of that type of work. Also, data minimization. We've gone through a big period where everyone saved everything. There's memory. Can you imagine how much memory in the world is full of information that no one's ever seen? So data minimization is a good example. And also data destruction. So if you've got some data, you want to work with it, don't need it anymore, then let it self-extinguish and build that into the code. So that's just a couple of examples of that. Yeah. Any more questions?
The tiniest, easiest question. If people want to keep talking to you about this, why don't
Yes.
they talk to you?
Oh, well, I did have a badge on. Come and see me. I've got a badge that's got my LinkedIn QR code, so you can come and scan me. Max, Michelle and myself, we're going to be putting as much information out as we can on LinkedIn and YouTube about what we're doing. And then obviously when the site goes live, that will hopefully be self-perpetuating. And you can come and take a look at what we're doing there. We're going to be launching Sustainable Engineering Magazine, LinkedIn executive briefings on sustainable design, and as much as we can to promote that as a subject. We think we'll probably end up in a sort of consultative role in some way, and we're working on that at the moment. So, yeah.
Let's thank
No more questions? Thank you.